So if I take ethylbenzene, treat it with Cl2 and H nu. So hopefully we remember from a couple of chapters ago, anytime you see H nu, what that means. That means light energy. Remember that E equal to H nu. That's the energy of a photon of light. It usually implies that there's a radical initiator. So there's a radical that's going to form from our benzene ring. Okay, there are several different possible radicals that could form. However, by far the most stable one is going to be the benzylic radical. This radical that forms the carbon alpha to the benzene ring, or next to the benzene ring. And hopefully we can see why as I go through and draw the potential resonance structures. And of course you can see that I'm drawing half-barbed arrows, because there's one electron moving in each case, instead of a pair of electrons. And hopefully you can see the same trend that you saw with positive charges and negative charges around the ring. And that is that the radical also can end up at the ortho pair of positions. So if I make this one radical over here at the benzylic position, there are actually 4 good resonance structures that I can draw. So this is a very stable radical. Okay, it's much better even than allo radicals, because allo radicals have 2 resonance structures that you can draw. A benzylic radical has 4 resonance structures that you can draw. So if that's the most stable radical, what would you expect for the product? Again, I would challenge you to pause the video and try to determine what you think would be the product before I move on. Hopefully you can now predict that you get radical halogenation at the benzylic position.